let's go on with the math. As usual, please feel free to stop me if you have questions. I'm going to tilt this down just a little bit to make sure it's in frame as best as possible. And yes, say things or type things if you have questions, concerns, comments. So last time we were evaluating some trig functions of inverse trig functions. So we're going to do something like this. So we're going to find sine of inverse cosine of -4/5. And there's really kind of, and actually we're going to do tangents as well. We're also going to do tangent of inverse cosine of -4/5. So I really want to stress that inverse cosine of some number, this is an angle, and I like to call it theta. And in fact, we can say a little bit more about this angle theta. We know what quadrant it's in. If I'm taking the inverse cosine of a negative number, am I in quadrant 1 or quadrant 2? You can either give me a thumbs up on camera, or you could even, I think there's a thumbs up button you can actually use somewhere. Maybe it's a yes or maybe it's a yes or a no, not a thumbs up or a thumbs down. Anyway, what are we in? Are we in quadrant 1 if it's inverse cosine of a negative, or are we in quadrant 2? I see the people whose faces I can see. I'm seeing some 2s, which is excellent. Yes, I see some 2s. Yeah, right? When you take inverse cosine of a negative number, well, that means it's the angle that if you took cosine of it, you would get a negative number. And to take cosine of an angle and get something negative, that angle had to be in quadrant 2, not quadrant 1. I mean, also quadrant 3, but we know we're stuck with quadrant 1 and quadrant 2. So if it's inverse cosine of a negative number, the angle has to be in quadrant 2. In a similar way, if it's inverse sine of a negative or inverse tangent of a negative, you know the angle is in quadrant 4. Okay, so now we're going to do the usual kind of thing. I'm going to draw this angle in a triangle. I'm going to completely ignore the negative sign. You don't have to ignore it. I like to ignore it. So what this is saying here is that cosine of theta is equal to -4/5. All right, that's what inverse cosine of -4/5 means. It's the angle that if you took cosine of that angle, you would get -4/5. So I'm going to make the adjacent side 4, the hypotenuse side 5. Yes, I'm ignoring the negative. You could throw on the negative there if you like. I don't really think you need to put it on there. I think you can just recognize that we're in quadrant 2 and figure out if it's supposed to be positive or negative by knowing it's in quadrant 2. That's why I spent so much time saying it's in quadrant 2. All right, then we find the third side. This is our typical 3, 4, 5 triangle. We know this side's going to be 3. We could also do the work, right? 4 squared plus b squared equals 5 squared. B squared equals 25 minus 16, which is 9. So b is the square root of 9, which is 3. You might notice my triangle, it doesn't really look like it's drawn right? The side that's longer is shorter, the side that looks shorter is longer. It doesn't really matter. So now, looking at this angle, sine of this angle is the opposite over the hypotenuse. So sine of inverse cosine of -4/5 is 3/5. And it is positive because we're in quadrant 2. And in quadrant 2, sine is positive. In a similar way, tangent of inverse cosine of -4/5 is equal to opposite over adjacent, which is 3/4. And since we're in quadrant 2, we know tangent is negative in quadrant 2. It's going to be -3/4. I will point out that if you kind of do the sides right and you get the negative sign where it's supposed to be, your tangent and your sine, whatever, will all come out to be the right sign, so you don't have to necessarily pay attention to the quadrant. I just think it's easier to pay attention to the quadrant. So I would do it that way, but you can also be like, oh, if it's negative 4 over 5, I know that the adjacent side is negative and the hypotenuse side is positive. But then I guess you don't really know if this is positive or negative unless you actually know what quadrant you're in. So I would still just use the quadrants. That's the way I'm going to talk about it. Let us do one more example. Wow, get close, it gets bright, get far away, it gets dark. It's interesting how the camera automatically kind of just adjusts. Let's do one more example like this, and then we'll talk about solving some trigonometric equations, which is very much in the same sort of realm as what we're doing with inverse trig functions. It's just kind of a little bit different. It's kind of like the difference between finding the square root of 9 versus solving x squared equal to 9. Right? This one, you're just evaluating a thing and saying, oh, I get 3. This one, you're finding all the solutions to this equation, which is we're about to kind of do this kind of thing where we find all the solutions to the equation. Anyway, that's not where we're not there yet. So one more example like this. I want to find sine of the inverse tangent of negative 4/5 and cosine of the inverse tangent of negative 4/5. And you can either type in the chat or show me on your fingers. Maybe I'll go to the gallery view for a second. I want you, so first of all, of course, inverse tangent is an angle, and I'm going to call it theta like I do every time. And now I either would love for you to type in the chat or show me on your fingers. I just made the chat small. Okay, there we go. Type in the chat or show me on your fingers what quadrant is this angle in. If I take the inverse tangent of a negative number, am I in quadrant 1, quadrant 2, quadrant 3, or quadrant 4? I saw one person. I saw someone put it right. Right, we know it's not quadrant 2 or quadrant 3 because that's not where inverse tangent lives. We know it's not quadrant 1 because that's where inverse tangent is positive. So where tangent's positive. So we know it's got to be quadrant 4 because that's where tangent is negative and inverse tangent either is in quadrant 1 or in quadrant 4. So theta is in quadrant 4. Also, I was noticing when I write my quadrants, sometimes I totally write like the regular numbers and sometimes I totally write like the Roman numerals. It's kind of a thing where people write Roman numerals for quadrants, but obviously I kind of go back and forth and don't really care which way I do it. So it doesn't matter, but I did notice I was doing it different ways. Oops. How do I pin my video again? There, pin video. Great, awesome. Okay, there I am on the screen. So this is the same thing, right? We're going to draw a triangle. Be careful. People like to try and trick you with a 3, 4, 5 that isn't a 3, 4, 5. Right? This is not a 3, 4, 5 triangle because tangent is opposite over adjacent. So again, I know what this really says here. If inverse tangent of negative 4/5 is equal to the angle theta, that's the same as saying tangent of the angle theta is equal to negative 4/5. And tangent is the opposite over adjacent. I think for inverse tangent especially, it's usually not really clear which of the, if it's negative, if it's the opposite's negative or the adjacent's negative. I don't want to worry about figuring which one it is, so I'm not going to think about it. I'm just like, hey, quadrant 4. That's all I need to know. But then I do need to find the hypotenuse here. So I know that, wow, you don't spell hypotenuse HPP, you spell HYP. I mean, that's the first 3 letters anyway. HYP. So I know that 5 squared plus 4 squared equals the hypotenuse squared. 25 plus 16 is 41. I think I forgot how to make letters. Sorry. Try it again. H, Y, P. And then finally, that's why you should call your things just one letter instead of 3 letters. You can't write letters. The hypotenuse is the square root of 41. So then, I'm going to erase this over here. I can say that the sine of the inverse tangent of -4/5 is the opposite over the hypotenuse, which is going to be 4 over the square root of 41, which I should rationalize as 4 root 41 over 41. And then since we're in quadrant 4, I know that sine is negative in quadrant 4. So it's really -4 root 41 or -4 root 41 over 41. In the similar way, cosine of inverse tangent of -4/5 is equal to, so let's see, cosine of this angle is adjacent over hypotenuse, which is 5 over root 41, which rationalizes to 5 root 41 over 41. And this one, since we're in quadrant 4, is going to be positive because cosine is positive in quadrant 4. You don't have to write the positive sign, but I kind of like, if I know it's like a question, whether or not the thing is positive or negative, I kind of like to write the positive to emphasize to the person grading my work, yeah, I know it's positive. I didn't just forget to write positive or negative. So you don't have to do that, but I like to do it. All right, so let us move on to solving some trig equations. So we're kind of going the other direction now. Meaning,
can I ask a question?
Of course, yes, please.
So on the example that we just did, can you go over like how do you find what quadrant it's in? Like how do we?
So here's, in fact, so I'm going to go to the other side. We'll come back. So here's what we know. We know that for theta equal to inverse cosine of x, right? Theta is an angle, inverse cosine of x gives us an angle. This gives us is an angle in either quadrant 1 or quadrant 2. And even more specifically, we know that inverse cosine of a positive number is in quadrant 1 because cosine of an angle in quadrant 1 is positive, right? Quadrant 1, everything is positive. And inverse cosine of a negative number has to be in quadrant 2. Again, for the same reason, because cosine of an angle in quadrant 2 is negative. And then we're going to say the same things for sine and for inverse sine, inverse tangent. So for inverse sine of x, or really even, I'm going to do them both at the same time because they have the same rules. So again, both of these are angles. Theta is an angle. Now for inverse sine and for inverse tangent, the angles we get out are not in quadrant 1 and quadrant 2, but in quadrant 1 and quadrant 4. Specifically, inverse sine of a positive number and inverse tangent of a positive number, those are both angles in quadrant 1. Because sine of an angle in quadrant 1 is positive, and because tangent of an angle in quadrant 1 is positive. And inverse sine of a negative value or inverse tangent of a negative value gives us an angle in quadrant 4. Because sine of an angle in quadrant 4 is negative, and because tangent of an angle in quadrant 4 is negative. So back to the other side. The way I knew this angle was in quadrant 4 was because I'm taking inverse tangent, meaning I have to be either an angle in quadrant 1 or quadrant 4, but it's inverse tangent of a negative, which means I have to be not in quadrant 1. Basically, if it's inverse trig function of a negative, you know you're not in quadrant 1, you're in the other quadrant. So for inverse cosine, it's the other quadrant is quadrant 2. For inverse sine or for inverse tangent, you're in the other quadrant, which is quadrant 4. It's a good question. It's a really good question, actually. Yeah.
Thank you.
You're very welcome. Thank you. You asked a good question. Helps everybody. Okay. So now, get my notes straight here. Yeah. So now we're going to solve some trigonometric equations. And so for all the equations I'm going to ask you to solve, we're going to be limited in our number of answers. Meaning, well, just let's look at the following example. So I want to solve the following equation. What do we got here? 2 times cosine of x plus 1 is equal to 0. Now, the issue here is that there's actually an infinite number of solutions. Because once you find one solution, you can just keep going all the way around the unit circle back to the same angle by adding on another 2 pi and get another solution. So I don't want to have to do that. I don't want you guys to have to do that. So what we typically do for questions like this is we limit our domain for our answers. We're going to say we're going to keep the values of x between 0 and 2 pi. We only want one full revolution's worth of answers because that really is all we need to know. And it's not a huge deal, but it really is, we want everything between 0 up to 2 pi, but not including 2 pi. So if you get 0 as an answer, you shouldn't also say that 2 pi is an answer because they're technically kind of the same angle. If you do accidentally say both of them, it's not a big deal. I won't knock you for it. But it will come up once or twice. All right, so to solve this equation, I'm usually going to just isolate my trig function. So I'm going to first subtract 1. So I'm going to say 2 cosine of x is equal to -1. And then I'm going to divide by 2. And say that cosine of x is equal to -1/2. Now, here's where what we just kind of did actually maybe isn't super helpful. You could find an answer by taking the inverse cosine of 1/2, right? So you could say an answer is x equal to the inverse cosine of -1/2. And that angle is 2 pi over 3. But that's not really the way I think I want to do it. That's not really the way I want you to do it. Here's what I would really rather you do. And I should say, I should be a little more specific when I write this question. When I say solve, what I mean is find all values of x that solve this equation. So you can find one answer, but we're not completely done until we find all the possible answers between 0 and 2 pi that are solutions here. So here's how I recommend solving this kind of equation. I really don't want to worry about if it's negative or positive in the beginning. I'm really just focused on where is cosine of x equal to +1/2. I know that's not the question I'm actually solving, but that's what I'm going to work on for just a second. So what angle is it in the first quadrant? Is it pi over 6 or is it pi over 30? We know it's not pi over 4.
Pi over 3.
Exactly. So it is pi over 3. And so here's what I want to say about that. That pi over 3 is essentially my reference angle. So now here's what I need to do. I need to go and say, well, I actually want cosine of x to equal negative 1/2. So I need to think about which quadrants cosine is negative in, and then find the actual angles in those quadrants that have pi over 3 as a reference angle. So first of all, which quadrant is cosine negative? Quadrant, well, not this one, it's positive there. Not this one, it's positive there. So it's got to be quadrant 2 and quadrant 3. So those are the quadrants I'm going to find answers in. And most of these equations are going to end up having 2 answers. Some of them have 1, some have 3. Those are kind of weird. Sometimes you get 4. Usually, most of the time, we get 2 answers. So I'm looking for an angle in quadrant 2, where pi over 3 is the reference angle. So I'm looking for, that's pi over 3. This angle is 2 pi over 3. And then I'm also looking for the angle in quadrant 3, where the reference angle is pi over 3. And that angle we know is pi plus pi over 3, which is 4 pi over 3. So these reference angles are really coming back here, right? We're going to use the reference angles to kind of find the reference angle and then to find the actual angles. So my answers here are that the angle x is either 2 pi over 3 or 4 pi over 3. And those are all of my answers to this equation between 0 and 2 pi. Right? There isn't an answer in the first quadrant. There isn't an answer in the fourth quadrant because cosine is positive there. And for the most part, that's the gist of what we're going to do for the rest of the day. We're going to solve trig equations like this. Sometimes they're going to be a little more complicated. But you can certainly use the idea of the inverse trig functions, but I don't think you have to. I mean, you kind of are whether you want to or not, but I don't think you have to explicitly write it out. I think I'm going to skip around a little. So in fact, I want to show you one where you do get more than just 2 answers. So let's look at, say, this one. Let's say I've got 2 cosine squared x minus 1 equals 0. Find all solutions where 0 is less than or equal to x is less than 2. You should generally assume if I'm writing the question that this is a condition on your question. Even if I forget to write it, you should still assume it. But I will try my best not to forget to write it. So we're trying to solve this, and if I could factor the left-hand side, I would, but I can't. I mean, you could factor this, it wouldn't be very nice. I'm not going to factor unless it really kind of makes sense to. Instead here, since I have just something squared kind of on its own, I'm going to isolate the cosine squared. So I'm going to say 2 cosine squared of x is equal to positive 1. I'm going to divide by 2 so that cosine squared of x is equal to 1/2. And now here's where you might make a mistake, I suppose. We know that cosine is equal to 1/2 when the angle is pi over 3. Right? It's definitely true that cosine of pi over 3 is equal to 1/2. But pi over 3 is not one of the answers here. Because cosine of pi over 3 is 1/2, but then cosine of pi over 3 squared is 1/2 quantity squared, which is 1/4. So pi over 3, not an answer. We have to do more work before we can actually figure out what we want. So this, I shouldn't cross this out, but this is not what we need. So we're going to take the square root of both sides. So we're going to get cosine of x over here, and we're going to get the square root of 1/2 over here. Now, I left something off, and I even left room for it. It's not just that cosine of x is equal to the square root of 1/2. It's actually that cosine of x is equal to plus or minus the square root of 1/2. In fact, just like when you solve x squared equal to 9, you get x equal to plus or minus the square root of 9, which is plus or minus 3. So generally, whenever you're solving something squared equals to a number, you're going to get a positive and a negative answer. Now, this might not look like a number we're used to seeing, but it actually is. We just have to rewrite it. So notice, so I can rewrite this as plus or minus the square root of 1 over the square root of 2, which is plus or minus 1, right? The square root of 1 is 1 over the square root of 2. And then I can rationalize this by multiplying by root 2 over root 2 to get plus or minus root 2 over 2. And that definitely looks like a number that we know cosine of x is equal to. So what is the reference angle here? It's the reference angle where cosine of that angle is equal to the square root of 2 over 2. Yep, pi over 4. Also, I do see that someone had to leave the class because their power went out. That is perfectly understandable. I mean, I don't want everybody saying their power went out because they don't want to be in class. But if your power goes out, there's nothing you can do about that. My power might go out, right? It is possible. Although I think they said rolling blackouts weren't supposed to be in effect here until from 3 to 10. So hopefully my power stays on. But yeah, if your power goes out, your power goes out. Okay, so here's the thing about this one. So we want pi over 4. And which quadrants do we want our answers to be in? Well, we want cosine to be positive or negative. So we actually want an answer in every quadrant. So typically, when you get cosine or sine or secant or cosecant to equal a positive, you can get positive or negative, you typically get an answer in every quadrant. So I'm going to get the answer in the first. So my answers are going to be x equal to pi over 4 in the first quadrant, 3 pi over 4 in the second quadrant, 5 pi over 4 in the third quadrant, and 7 pi over 4 in the fourth quadrant. So usually it just ends up being every special angle that has the angle you need as the reference angle. And that'll happen a lot of the time when you have like something squared equal to just a number. Okay, let's look at, oh yeah, we got plenty of time. So, no, come on. Board's a little wobbly here. Okay, so look at another. So some of these examples are going to look kind of weird. Like here's an example. I want to solve 3 times cosecant of theta equal to the square root of 12. Again, where theta, or the angle, is between 0 and 2 pi. Now here's what I'm going to say generally. When I write these kinds of questions, the answers are always going to be special angles. I'm never going to make it some weird like thing. So what you should be thinking then when you see something like this is eventually something should equal something that looks kind of normal to me, like sine equals 1/2, or the square root of 3 over 2, or the square root of 2 over 2, or 1 or 0, right? There should be some sort of normal-ish thing showing up. So let's work on it. So here's what I would say first. I'm going to simplify the square root of 12. Square root of 12 is the square root of 4 times 3, which is the square root of 4 times the square root of 3, which is 2 times the square root of 3, which already looks better. At least I've got square roots that seem reasonable to me. So I'm going to rewrite my equation as 3 times cosecant of theta equals 2 times the square root of 3. And then you can divide both sides by 3. So the cosecant of theta is equal to 2 root 3 over 3. Now, I know that that's a value that cosecant usually equals, but it is not one that sticks in my head very well. So here's what I would say. I would usually do the following. I would change cosecant into 1 over sine. I would write this as 1 over sine of theta equals 2 root 3 over 3. And then I would flip them both over. So if two fractions are equal to each other, their reciprocals are also equal to each other. Has to be true. So if these are equal, it's also true that sine of theta over 1, which is just sine of theta, is equal to 3 over 2 root 3. And then we can simplify this. You can either do the rationalization, or you can just say that 3 divided by the square root of 3 is the square root of 3. So this becomes the square root of 3 over 2. But I'll show the rationalization. So if I multiply by root 3 over root 3, I get sine of theta equal to 3 root 3 over 2 times root 3 times root 3 is 3. And then these 3's cancel out. So I end up with sine of theta equal to the square root of 3 over 2. Whew. So it took a little bit of work, but eventually we got this to look like a trig function of an angle equal to one of the normal values we're used to seeing. So then, what's the reference angle? Is it pi over 3 or is it pi over 6? Nobody wants to tell me the reference angle?
Pi over 6.
You're so close.
3.
That would be if cosine was equal to root 3 over 2. It is pi over 3. But I appreciate your guessing, you're giving a brave answer. It's hard to sometimes guess if you're not sure. But yeah, so remember, root 3 over 2 is the bigger value, and so you're going to get the bigger angle. So our actual answers are going to be answers in quadrants 1 and quadrants 2, where sine is positive. So I'm going to get, so that's a nice thing. If you're in quadrant 1, your reference angle is just one of your answers. So we're going to get pi over 3, and in quadrant 2, we're going to get 2 pi over 3. Okay. All right, I got lots more of these. It's like great, super exciting. Okay, let's try this one. Let's try secant theta minus 2 equal to 0. So just like most of these so far, you're going to want to isolate your trig function. So I would totally, I mean, this one is pretty straightforward-ish, I think. Oh, and again, right, of course, 0 is less than or equal to theta is less than or equal to 2 pi. So I'm going to isolate secant. Secant theta is equal to 2. And then again, I might remember where secant is equal to 2, but for me, it's just easier to use sines and cosines. So I would rather write this as 1 over cosine of theta equals 2, which means cosine theta equals 1/2. You can think of flipping both of these over. You can also think of multiplying. You can also just say, I'm going to multiply both sides by cosine. So 1 equals 2 times cosine theta. and then divide both sides by 2 so that 1/2 equals cosine theta. Or you can just flip them both over. It's the same result either way. So then, where does cosine theta equal 1/2? Well, another reference angle is pi over 3. Just like sine of theta equals root 3 over 2, the reference angle is pi over 3. If sine is root 3 over 2, cosine is 1/2, and vice versa. If sine is 1/2, cosine is root 3 over 2 at the same angle. So I know that sine is root 3 over 2 at the same angle as cosine being equal to 1/2. So my reference angle is pi over 3. So my answers are pi over 3 in quadrant 1. And then my other answer is in which quadrant?
Quadrant 4.
Yeah. So that's going to be 5 pi over 3 in quadrant 4. Okay. More. Okay, that was all. So normally, normally, nothing is normal anymore. Watched an episode of a TV show called last night. The episode was titled The New Abnormal, which I thought was very appropriate. But normally, in a regular classroom setting, I would probably have you guys work on some problems now and walk around and look what you were doing. But since that doesn't really seem very plausible at the moment, I will keep doing examples and you can keep kind of chiming in. So let's do another example. Let's look at, oh, in fact, yeah, we're gonna do 2 examples in one. So let's look at 3 tangent squared theta equal to 1. And then we're gonna leave myself a little bit of room over here. And again, theta is between 0 and 2 pi. Okay. And something to recognize right now, since I've just got tangent squared, well, in fact, let's isolate tangent squared. So I've got tangent squared theta equal to 1 over 3. I can see, and I think you guys will be able to see pretty quickly, that in this case, tangent is going to end up being positive or negative, which means we're probably going to get answers in every quadrant. That's not always 100% true, and I'll show you an example of that where it's not in just a second, but most of the time it's pretty true. So if I solve this, I'm going to get tangent of theta equal to plus or minus the square root of 1/3. And the square root of 1/3 you should immediately simplify as plus or minus 1 over the square root of 3. I did skip a step there, right? The step I'm skipping is writing it as the square root of 1 over the square root of 3, and then the square root of 1 is just 1. I think that's a perfectly fine step to skip. And then I would rationalize this as plus or minus root 3 over 3. And then we have to remember which angle is it where tangent is equal to root 3 over 3. Is it pi over 6 or is it pi over 3? Pi over 6. Tangent of pi over 6 is root 3 over 3. Tangent of pi over 3 is bigger. It's just root 3. So tangent and sine are actually kind of similar in that in the first quadrant, as the angle gets bigger from 0 to pi over 2, both sine and cosine get larger, right? Sine is 0, 1/2, root 2 over 2, root 3 over 2, 1. Tangent similarly is 0, 1 over root 3, 1, root 3, undefined. So yeah. There's a trick to remembering things that there's like a finger thing some of you may have heard of, remembering sine and cosine. I'm not good at it, but I can maybe talk to you about it. It's not, I don't think it's super fun, but maybe if we have time later on, I'll talk about it. So reference angle is pi over 6, but we know that we want answers in both the first, third, second, and fourth quadrant because We want tangent to be negative, sorry, we want tangent to be positive in quadrants 1 and 3. We tangent to be negative in quadrants 2 and 4. So we want all the angles where the reference angle is pi over 6. So we want theta equal to pi over 6 and 5 pi over 6 in quadrant 2 and 7 pi over 6 in quadrant 3 and 11 pi over 6 in quadrant 4. Right? All the multiples of pi over 6 that don't reduce. I wanted to contrast this with, on the other hand, if you were just solving tangent of theta equal to 1 over root 3, which is root 3 over 3, you wouldn't get all these answers. You would only get the answers where tangent was positive. So here, the answers would just be pi over 6 in quadrant 1 and 7 pi over 6 in quadrant 3, because those are the quadrants where tangent is positive. How much time do we got? Out of 10, okay. So I did say that when you have something squared, you often get more than just 2 answers. It's not always the case though, especially if your angles end up being like quadrantal angles. So here's a different example. I want to solve cosine squared of theta minus 1 is equal to 0. And there's a couple different ways you can see this. And they're both valid. One way is to do what we've been doing. Say cosine squared theta equals 1, and then square root both sides. So cosine of theta equals plus or minus the square root of 1. But the square root of 1 is just 1. So cosine theta equals plus or minus 1. And again, of course, theta is between 0 and 2 pi. So where does cosine of theta equal negative 1? What quadrantal angle is that? 0, pi over 2, pi, 3 pi over 2, or 2 pi? Oh, I know which one it's not. It's not 2 pi, because 2 pi is not allowed. All right, which angle is it, everybody? Cosine is the, oh, you guys are writing things in the chat and then not seeing it at all. Yes, people who have written pi, you are correct, thank you. Definitely the angle is pi. Okay, what about cosine equal to positive 1? What angle is that? Well, we know it's pi. So Sean and Adrian, you're both on the right track, except 2 pi actually isn't an angle that's allowed the way we've written it. So yes, it's more correct, Diana, to write that the angle is actually 0. Now again, I will point out, generally, I'm not going to knock you for making that mistake, but technically the way this is written, we want to either pick 0 or 2 pi and not both. So we decide to default to 0. So the answers to this equation are theta equals pi or theta equals 0. The other way I was going to say you could solve this is by factoring. It ends up being the same though. You can factor this as cosine theta minus 1 times cosine theta plus 1 equal to 0. And then you get the same result. And then if you could even use a trig identity, right? There is like a negative sine squared there. I wouldn't use trig identities in these problems unless it really seems like that's what you were wanting to do. Most of the time, that is not the intention for these. Let's see, what else have I got here? Yeah. Let me do one more. I know we're almost out of time, but I wanted to do one more. So I think there's one like this, either in the homework or in the practice test. sine squared x minus sine of x is equal to 0. Yeah. So here is where it's really, really important that we are safe, are careful. When you have something like this, or let's actually, I'm going to change it a little bit. Let's pretend we started with this. Sine squared x equal to sine of x, which is the same equation, just written differently. So what I really, really, really want to say here is we should not divide both sides by sine of x. Because what will happen is we will lose solutions. So I will show you what happens if we do that after we do it the right way. So here's the right way. And I'll say just more generally, when you're solving equations, it's almost never right to divide by a variable. Like for example, if you were solving x squared equal to 2x, if you divided both sides by x, sure, you would get the answer x equal to 2, but you'd be missing the answer x equal to 0. Because 0 is definitely a solution of this equation. So dividing by a variable often makes us lose a solution. All right, I know it's 220, so I'm going to work real quick. So we subtract sine of x, because we want 0 on the other side. We factor out a sine. So we're left with sine of x times sine of x minus 1. So if we distribute this back through, it would be sine squared x minus sine of x. And then if two things multiply to 0, either one of them has to be 0. So either sine of x is equal to 0. The angles that make sine equal to 0 are either 0 or pi, not 2 pi, because again, it's just the first thing we don't want. And then sine of x equal minus 1 equal to 0. That's going to be sine of x equal to 1, which is going to be x equal to pi over 2. So that's how you would solve an equation like this. Again, when you've got kind of a lot going on, you're not exactly sure what to do, you want to bring everything to one side, have 0 on the other side, factor the side as much as possible, and then set each factor equal to 0 and solve it.